Welcome to the quantum world, an invisible universe hiding beneath everything you know. In the next 9 minutes, we'll explore waves, particles, and the strange rules that govern the tiniest building blocks of reality. Quantum mechanics is the science of the very small, smaller than atoms, smaller than electrons, smaller than anything you can see. In this realm, the rules of everyday life break down. Objects appear to be in two places at once. Particles pass through barriers, and probability becomes more important than certainty. One of the biggest surprises of quantum physics is that everything, light, matter, even energy, behaves both like a particle and like a wave. Not one or the other, both. A particle is a tiny point, like a speck. A wave is spread out, like ripples on water. Quantum objects switch between the two depending on how we look at them. The most famous example of wave-particle duality comes from the double-slit experiment. When we fire a single particle, like an electron, through two tiny openings, something strange happens. If we don't observe it, the particle behaves like a wave. It spreads out, interferes with itself, and creates a pattern as if it passed through both slits at the same time. But if we watch it closely, it snaps into particle mode. No wave behavior, no interference pattern, just a dot hitting the detector. In quantum mechanics, observation changes reality. Another pillar of the quantum world is the uncertainty principle, discovered by Werner Heisenberg. It tells us we can never know everything about a particle at once. The more precisely we know its position, the less precisely we know its speed. And the more we know its speed, the less we know where it is. This isn't a limitation of our tools. It is a fundamental rule of nature. One of the most mind-bending quantum ideas is superposition. A particle doesn't choose one position until it is measured. Before that, it exists in many possible states at once. Think of it like a coin spinning in the air. While spinning, it's not heads or tails, it's both. Only when it lands do we get one answer. In the quantum world, things stay spinning until we observe them. Einstein called this next phenomenon spooky action at a distance. It's called quantum entanglement. When two particles become entangled, they share a connection that defies normal space and time. Measure one particle here, and the other instantly responds, even if it's across the universe. We don't yet fully understand why this happens, but we can measure it. And we can use it, like in early quantum computers and encrypted communication. In the quantum world, particles can tunnel through obstacles they shouldn't have the energy to cross. This quantum trick is the reason the sun shines. It's also the principle behind your smartphone's flash memory. Quantum tunneling, the universe's tiny cheat code. Quantum mechanics isn't just a scientific curiosity. It shapes our modern world. Lasers rely on quantum physics. So do MRI machines, computer chips, and atomic clocks, the devices that keep GPS accurate. And now, quantum computers are emerging, using superposition and entanglement to solve problems classical computers can't touch. Despite a century of research, the quantum world remains mysterious. No one fully agrees on what quantum mechanics means, only that it works, beautifully, powerfully, and sometimes unbelievably. The quantum world is strange. It's unpredictable, and it's the foundation of everything. If you enjoyed this journey into waves, particles, and weirdness, make sure to subscribe for more mind-bending science. The universe is full of mysteries, and we're just getting started. Do you have a subject you'd like to hear more about? Let us know in the comments and stay curious, because there's always more to explore.